Good evening, everyone. Good evening, all of you. Yes, I can see your chats. You all are excited for the data visualization today. Yeah, good evening, Mukta. Good evening. Good evening, Channa. Good evening, Papiha. Good evening, ES, and good evening, Hamza. A very good evening to all of you. I welcome you all to the day one of the data visualization essentials. Yes, Ritik. Its session will be available later. Yeah. Good evening, everyone. Ayushi, I can see your chats. So let's have a quick interaction with you all. Just guys, tell me from where all you are, like from where you are seeing the chat, this session. I am live from Kurukshetra, Haryana right now, and from all, from where you all are. Just tell me. New Delhi, Guntar, Bangalore, Gujarat, Mumbai, Andhra Pradesh. Oh, Earth. I am also from the Earth, Agarwal. Oh, yeah, I can see your chats and it's running very fast. Pune, Rajasthan, Gujarat. Okay, Delhi, Kanpur, Faridabad, Chennai. Yes, I can see people are from all over the country. So let's start the session today. I know you all are excited to learn, but before starting the session, I would like to make you some announcements regarding the session. This will be 3 days course for the study, and last day will be the career session. And you all will be getting the certificates. There will be two kind of certificates. One is for participation, and second is completion certificate. And for the participation certificate, you all guys need to mark your attendance daily. The attendance link will be there in the description, and also our moderators will be giving it in the chats. And for the completion certificate, you guys have to mark your assignments and fill your assignments timely on the assignment submission form. It's there in the description. And assignments, don't worry guys, assignments and materials will be posted on the community after the session, so please go through it. And one more important announcement is that please, to mark your attendance and to join the community, please make sure you have registered or enrolled for the course. And the registration link is going through the chat. Yes, registration link is there in the chat. You guys can register for the course, and also make sure you all have account at LetsUpgrade.in. Okay, so I think this all announcements are clear to all of you. Now I would like to introduce to trainer. Yeah. Good evening, sir.
Hi,
How are you,
hi,
sir?
am I audible?
Yes, sir. Audible, audible.
Yeah. Hi, good evening. Good evening,
Yeah.
guys.
He's a very good trainer. I assure you all, guys. He will be teaching you a lot. You will learn a lot new things from him. So it's all to you, sir. Now you can take ahead.
Sure, sure. Thank you, ma'am.
Yeah.
So,
Sure.
good evening, guys. Welcome to this session on data visualization. So, you can ping your doubts in the chat. And first of all, I want to know that do you guys have the Jupyter notebook installed? Yeah. Hi, good evening. All right. So, just in case if someone is not able to install it, so you can go to the Jupyter website, the organization, and you can download from here. And you have the Anaconda and pip install statements here, and you can run them in your command prompt, and you can have the installation. Right. So, coming to the topic in focus. So, our topic for today is the library for visualization that we use in Python, which is Matplotlib. So basically, like if we talk about Python, So why is Python getting so much popular these days? Why every engineer or person who is trying to get into the field of data science and machine learning is going towards Python? This is because Python offers a large variety of libraries which consists of functions that we can use to gain whatever we require and find a solution to it. So for instance, like we know in data science it's all about data, right? So, in order to visualize that data, we need some libraries. So, there are people who are doing PhD and who are developers, and what they try to do is they make a library, they inbuild some kind of functions in it, and what we have to do is import that library and use those functions. And we'll see the functionality just in front of our screens. So, talking about Matplotlib, so why should we study Matplotlib? There are other libraries available, but why Matplotlib is the first library when we talk about when we think of data visualization in Python? So, Python offers a large variety of libraries other than Matplotlib, but Matplotlib is the first stepping stone towards learning data science visualization. So, it is really good for beginners in terms who really want to learn data science and machine learning. It is one of the most popular and frequently used visualization library in Python, and it is based on NumPy. So you must have like learned about NumPy and Pandas, and if you have not, then there is no worry about it. I'll make you go through the code. So talking about Matplotlib, it offers an object-oriented API experience for embedding plots into applications. So basically, Matplotlib is a low graph plotting library in Python, which serves as a visualization utility. It is open source, that is why we can use it freely, and it is mostly written in Python, but there are some aspects that are covered in C++ and JavaScript as well. So let's go on to the installation and the import. So you can install the Matplotlib using Anaconda environment tab or by executing the following in your terminal, which is pip install Matplotlib. So if you go on to, so I am commenting out this code because I already have this installed in my local PC. So when it runs, it already says that requirement already satisfied. But if you don't have it installed on your PC, you can go through it. So I'm commenting out this. Now let's import Matplotlib. So this was about the installation. So this command runs fine. See, a few more aspects about this Jupyter notebook. So there are a lot of features offered by Jupyter. Like, see, I've written about some theory about Matplotlib. You can click this cell and you can view out that I have used HTML tags inside this. So Jupyter offers this functionality where you can use HTML within the markdown blocks. So there are also a variety of shortcuts available. Like you can go for the shortcuts and you can understand that how to turn a cell into markdown and how to turn a cell into the code cell. So if I press escape M, then this becomes a markdown. I press enter plus shift, then this markdown cell runs. Similarly, this is the code for the Jupyter organization. And this is another markdown cell and this is another markdown cell. So this is the kind of functionality Jupyter provides us. So that is why it is very popular among data scientists. Next, coming on to the importation of Matplotlib, this runs fine. So I have like installed and imported both. Both the functionalities are done and it has been working properly. Next, I would like to go for a statement which is modular and inline. So modular inline basically represents that if you want something to be present on your specific screen, by specific screen I mean in our case the Jupyter notebook. So we'll mention the library which we want within these two terms. So if I write this and if I run it, so what this statement will do is whatever charts and visualization that we are going to do with the help of Matplotlib, they will be visible to us in this specific Jupyter notebook. So it is important if we are working in a Jupyter notebook, else we have to write some additional statements if we are working in some other kind of environment. Now coming to another part. So there is a function known as pyplot. So we'll be importing that because we are basically working on pyplot from the matplotlib library. Now let's understand the statement. PLT here is an alias. By alias in layman terms, alias means nickname. So we all have nicknames at our home, right? So that is why our family doesn't have to call our whole name. So whenever in our code we have to use this pyplot, which is imported from the matplotlib library, then we can simply write PLT and we can use it. So this will help us further, and this will also reduce the number of lines of code which we will have to do if we are not using this alias. So if I can comment out this, that PLT is an alias, and I can turn this cell into a markdown, right? So I have imported this. Another way, you can do is, this was the shorthand, right? So you can directly write from matplotlib. Now I have written mat, right? You can press tab and you can see the options that are available in Jupyter. So I can choose matplotlib, and inside matplotlib I need which function, which is pyplot. So I'll write pyplot, and I can remove this from, and I can write import. So these two lines are doing the same thing, but this is a shorthand thing and this is the full length thing. So if you want to import some function from a specific library, you can use the dot operator as well. Now, coming to the first plot of our matplotlib that we will discuss is line plot. So inside the matplotlib, there is a function known as pyplot, which has another function which is plt dot plot. So if I go on to this link, so this is the documentation for matplotlib. Everything I'm going through in this session, like you can go through the advancements of that in this documentation. So just press Control F in this documentation and write plot. So once you go down, so there is the function that we want to use. So what it does is it plots y versus x as lines or as markers. So now let's see what happens. So for each and everything regarding to matplotlib, you can refer to this documentation. So if I write PLT, which is our alias, and we put a dot operator, and then we press tab, so we will be represented with each and every function that is present inside this pyplot function. So if we can drop down, we can find a whole lot of variety of functions that are present. So the ones that we are going to use is the plot. Now again, if I press shift and tab, then I'll be presented with the documentation that is provided by Jupyter, which will have the definition of the function as well as the parameters that will be used inside it. So let's first define it. Now, inside this, I need to pass two lists. So I get this line. Now let's understand what has happened. This PLT is the alias name. This plot is the function that we are using. And inside this, we are passing the data that we want to represent, right? So if we press shift and tab just after the plot, we'll be able to understand what are the arguments that are being used. So plot xy. So our this list is the x that we are passing, and our this list will be acting as the y. So the plot will be like 1 comma 2, 2 comma 5, and 3 comma 7. Further, there are a lot of arguments that are available and parameters also. So like this fmt, this is optional. So even if we don't mention anything about this argument, our code will run fine. So that is why it is running. So basically, concluding this, the plot function is used to draw points or markers in a diagram. By default, the plot function draws the line from point to point, and the function takes parameters for specifying point in this diagram. Now, this 1 comma 2 is marked here. This 2 comma 5 is here, and this 3 comma 7 is here. But like it is getting very tedious to understand our checkpoints, right? Like the points that we are marking, this shows the relation between these 2 points, but we want to see the markers as well. So next, what we'll try is, first we'll customize this a little bit. So for example, if we want to give this plot a heading and labels for the x and y axis, so this is the x axis and this is the y axis. So again, I'll copy this data itself. Now plt has a functionality known as title. Like if you can scroll down, you'll find title inside. So here it is. Now press shift and tab. So this asks for the label, the font depth. These are all optional, right? So the basic one is we have to provide the label that we want to be presented in this plot. So let's write our data. And similarly, we want to name the x-axis and the y-axis. So for that, we'll use x label. This is x-axis. And similarly, we can do this for the y-axis as well. Just we have to turn this x label into y label. So now see, our heading comes up here, our data, our axis have been named now. This is x-axis and this is y-axis. Now coming back to a point that I wanted to show, that this specific line, what I told was that we are using this line so that our visualizations come here in our Jupyter notebook. But this is the line that is extra. For instance, if we don't write this line, then will this plot get printed or not? It does. So this is happening because we are using this modulus matplotlib inline. And if we don't use this matplotlib inline, then we have to use the plt.show. Then our plot will be shown. So this line can be removed from here. This is an extra line and our graph shows fine. Now coming to the change of the font size and the size style of the title. Now this is very simple, right? If you want to customize this a little bit, we can use the same code and customize this. So for those functionalities, we'll require some kind of attributes. So let's understand about font depth. A font depth controlling the appearance of the title text. The default font text is this. So if we want to change the style of the title, we have to use this parameter, which is font depth. If I press tab, then this should run. inside the font dict. So as the name represents, this is a dictionary, and we have to use a key value pair inside this to change the customization. So the first parameter that I want to change is the font name. So I want to change the font basically. So a popular font is, and at the same time I want to change the font size. And I'll change it to 20. This is showing an invalid index. Okay. So I have missed out on a few. Okay. So here we can see the changes. So the style of the font is changed, and similarly, if I pass it as a key, the font size is also changed. Now you can see that our data has been bigger than this. So this is how you can play with the plot function. And similarly, if you want to save this file, so what you can do is you can do plt dot save and press tab, so that will complete it on our own, and you have to just mention the file name. So I'll mention it as our data and the extension of the file .png. If I run this and if I go, so I can see this file, this figure has been saved. So this is how you save a file. Now the fonts that we have applied to our title can be applied to the labels as well. So for that, we'll copy this data, and similarly, these two can be passed on to the label. Now let's see. This is the x-axis. So the font size and the font style has changed. Now, if you want to see, like I have mentioned this out of nowhere, brush script empty. So most of you will not be knowing that this is a type of the font that is available. So to see the list, you can refer to this link. And this is all the fonts that are available in Python, and you can use any of them. So just you have to mention this name and this type of font will be available. So you can play around with this. Now, if you can if you guys can see in our x-axis, we are able to view these values as integers like 1.00, 1.25. What if uh, our requirement is such that we only want one, so we don't want the decimal part? So to complete it into the whole integer values, we can change these sticks. Let's see how it works. You have to copy this data, and we can use x, we can type x and we can see ticks. So if we pass on the value that we have passed into our plot function, then we'll be able to get the ticks out of the same data. Let's run it and see the difference. So see now, there is no decimal point and we can view it as the whole integer. Now, if we require to plot two lines in one single chart or plot for comparison reasons, say if we want to see that a restaurant is having reviews on two different platforms, and if we want to compare those reviews of the two different platforms, we can plot it using the dot plot function. So let's take some new data this time. I'll make a list named X and another named Y. Similarly, I'll take two more variables named say X2. So on running this, we can see two different lines. So what I did was took two variables named X and Y, gave it a list and two more variables X2 and Y2, and passed two more lists to it. Now the first plot that we want to make is of XY. So you can see this line 1 comma 11 here, 5 comma 15 here, and 4 comma 19 here. Similarly for X2 and Y2, you can see 3 comma 5 here, 7 comma 8 here, and 3 comma 9 here. So I know this is a this is a bit fussy. If we have more linear data points, then these two lines will be very linear to each other, and that will give us a very good visualization. But sometimes the data is not as such. Real time data is very messy in its own. So yeah, you have to deal with this. Now the background of this chart, like it's plain white, right? So in case if you want to change the background of it, so there is something known as style. So from matplotlib itself, if we can import another function, which is style, then we can change the background of this. And to view the various types of styles that are present, you can check out this link. So this is the matplotlib documentation again, and you can view the various styles that are present. So let's pick up the same code. And just before plotting it, let's use the style. So if we write style in a dot function, then we can see the inside variables and we'll use the use function. And I'll mention a type of style which is ggplot, which stands for grid grid plot. So now you can see the difference that the background is turned into grid grid plot. So this is how you can play with the styles. Now next, we wanted to show that this is the x axis and it responds to the x label, and this is the y axis which responds to the y label, but this is not shown in the graph. So for that, we want to get the scale here. We'll have to use the label function. So copying the same code, and this time we'll have to give it a label as well. So this won't run. And why it won't? Because we have to mention a method explicitly, like we have to write another line of code, because if we are mentioning the labels as well, still we are not getting the scale here, right? So for that, what we can do is, there is another function known as legend. So if we run this legend explicitly, we can view the scale here in our graph itself. So all these are the various arguments that are present inside the plot function only. So you can play around with each and every attribute and parameters, and you can see some kind of change in your visualization. So as per your requirements, you can play around and you can get the desired result. So there is another parameter present inside the plot function, which is line width. So let's see how it goes. So if you want to change the width of this line, so for this, we can use the line width parameter. And here in the plot for the x and y, I can mention line width say is equal to 5, and let's see the change. So our line gets broader. So sometimes if you want to make a relationship stand out, so this is how you can make this x and y regression line stand out from the other one. So this was about the plot function. If you guys have any doubt regarding this, like you can tell me in the chat. All right. So yes, there is a doubt that can we make the y-axis start from 1? Yes, but our data is accessed that as per visualization, we want to show the points. So this is not about like rearranging the axis, because if we rearrange the y-axis from 1, so this line will be very timid here. Like it will show very little of the visualization. So by default, Matplotlib, what it does is that it makes sure that the point in contention are highlighted properly. So to the like for the question that you are saying that can we make the y-axis one? Yes, we can, but we have to change a lot in the parameters to achieve that, and that won't give the desired visualization. Yeah, Manoj, you will get the Jupyter file. Don't worry about this. Just understand the coding that is being done, and you'll get the Jupyter file. So you don't need to do the hands-on simultaneously. So, all right, let's go on to the another plot that is available in Matplotlib, which is the scattered plot. So we have learned about the basic plot function wherein the lines are plotted, and now we'll understand about scatter plot. So this comes very handy in projects when you are dealing with machine learning and data science, and this will help you get various insights during your exploratory data analysis. So I'm using the style as ggplot. Let me use the same data. This time I'll be using some bigger values so that your question can be answered about the y-axis. So again, inside our plot function, we'll have scatter. Now let's understand about the scatter plot. So the scatter is a function inside our plot pyplot library. So a scatter plot of y versus x with variable marker size and an or color. So the parameters are x and y. So let's pass the parameters, say x, comma, y, and label this as first scatter. Line width, let's choose this time 3. And let's see the plot function with it. So you can see the difference between plot and scatter on the same line. And for the scale to be viewed on the graph, we have to use legend. Okay. See now, the first comparison of the lines x and y are shown by dots, and the second one is shown through a line. So this is how the scatter plot works. So you will get each point will be represented as a dot. So like for instance, the first point was 1 and 23, so it is mentioned as 1 and 23 with a dot. So this is how scatter plot works. It is on the same lines with the plot function, but the only difference is that instead of a line, you get a dot. So now let's experiment with some NumPy applications. For that, I have to import NumPy as NP. So if like any of you is completely new to Python, so NumPy is basically numerical Python, and it gives the functionality of arrays, which is a data structure, to Python to store the data. So again, and NumPy is being imported as an alias with the name NP, and it has a function arrange. So this will give us 10 integers. Like if you print D out here, so this is an array 1, 2, 3, 4, 5 up till 9. So the one and the last point, the stop point is not included in this. So that's why we are getting the array from 1 to 9. So let's try to get the square out of this. For that, I'll need another variable. So I'll do z. So z will have the square of each value of this. And let's see how we can plot it. This line was not run. So now you can see the curve for the square, right? But like we are getting the same colors for the line like red and blue. Let's try to change it a bit. So we'll use another parameter known as color, and we can pass say y. So the color of the line changes. So now let me make you shift tab, and you will get the various parameters. So inside that we'll understand. So x and y is what we have discussed, the data points that we want to plot. FMT was optional, and besides that, so these are the colors that are available inside the plot function that you can use. So for the color blue, you will have to use alphabet B. And similarly, for these colors, you have to use the respective alphabets. Also, there is a thing known as color picker tool. So if we Google out color picker tool, so this will have each and every pixel as different color. So if we want to use this color, we'll copy the hashtag code and we can paste it inside our color, and you can see that it implements in the same color. So this is why like Python offers a variety of functionalities, and this is one such functionality where you are not restricted to use specific amount of colors and specific amount of functionalities. You can go out on Google Color Picker and use this color or any other color which you want. So let's try out some other line color. Say for example C, and now you can see the cyanide color. Now, if you want this line to be visualized as a dashed line, for that we'll use another variable which is known as line style. So this is an optional variable, and by default you'll get a straight line. So let's mention it as dashed. So now you can see that the line that we were getting is now in a dashed form. Now, as we were discussing that this visualization is quite boring in terms of we are not getting the markers. The markers as in the first point that is highlighted here should be marked like significantly. So for that, we'll use markers. Again, the type of marker which we'll be using, we can check it out inside the plot. So these are the variety of markers that are present inside this plot function, and you can use any of them. Say, let's use a star marker. See, now our checkpoints are highlighted with a star. And also you can change the size of the marker as well. Say let's 20. So now these are represented significantly. Like I've told you about entering shift and tab to see the options for all the other attributes. So you can view out all other attributes and play with it. So they might help your visualization or they might not. So you can try it out on your own and mark it as an exercise for your better understanding. So these were the parameters related to plot that were significantly important. So we had discussed them. Just in case, like if you want some other parameters to be used, let's take the color this time as say green. The marker as say if you want single dot line. The line style as dashed. Similarly, line width. And we have learned about marker size now. Let's try to get the markers color changed as well. So for that, there is a thing known as marker edge color. So I missed out on an equal to out here. So now you can see our visualization has certainly improved a lot. So you can see the marker point as well, and they are further highlighted with another color. So if you don't want to write this code, like you think that this is getting too hectic to write all these attributes, so there is a shortcut for at least the color marker and line style. So for that, what we can do is plt.plot, just pass on the data, and when you have to choose the color marker and lifestyle, you can mention it inside a comma, the inverted comma, and you can write it in this way. Like for the color, if you are choosing green and the marker you want is a dot and the line style you want is double dash. So this is a hack that you can use, and say the rest of the parameters are line width equal to 5. So see, we can get the similar code, but for the color, marker, and line style, we can use this shorthand as well. Now, if you want to change this projection, like if you want to customize this projection, for instance, if this point is a very important point, and if you want to highlight that after this point, our projection increases like periodically, so we can customize that as well. So for that, let me take another array. So inside this array, like what I'm doing is I'm taking the starting point as 0, and it will take the points into consideration till 4.5, and you can apply a stepper of 0.5. So what will it do is it will give us an array starting from 0 till 4.5 at an interval of zero point 0.5. So we'll be having the numbers like this one. 0, 0.5, 1, 1.5, 2, and up till 4. So the last point is not considered. So up till 4, we'll get the array. Now let's try to plot it. So I'm using the slicing here. Let's keep it inside normal commas. Because it's not required. And similarly, for the change that we want to show, we can give some other kind of color which will be reflected. Okay. Now you can see that after a certain point of time, our projection changes. So the customization is done through the use of slicing. So what we have done is inside this array, after the sixth point, the projection will be turned to the cyanide color. So before 6, like we have mentioned it for the R color, and after 6, we have mentioned it as blue color. So this is how you can play around with the customization of the projection. Now let's try to get a bigger figure. Like if you find this figure small, we can change the size of this figure as well. We can mention the fixed size as 5,3, which is the default size, and API, which is the pixel. Let's try to plot the C1 into it. So now you can see that our figure size has changed, and this is done by using this attribute known as figure, and inside we have mentioned the parameters of fixed size and DPI. These are the various colors that were present that I told you. This I got out only with the help of Jupyter only. So like you can press Shift and Tab, and then you can get the list of this color. And I've mentioned it inside a markdown cell. Next, coming on to the subplots. So what if you want to plot a variety of plots inside one single plot? So for that, let's try to write some code and use a function which is known as subplot. If you can press the tab button after it, you can find this function available. So let's understand what the syntax is doing. So first three and the second three, this is the order of the plot that we want to show. This shows that we are plotting a 3 by 3 plot, which will have total a 3 into 3, 9 plots. And this specific plot is for the first position. So the parameters are named like number of columns, comma, number of rows first, and then the index that you are mentioning. Now let's try to print this by completing the code, and suppose so we are passing the data points as x and y, and the color should be M, and it should be represented with a dashed line. So this is the shorthand that I have used. Similarly, the second graph should be like the index should be changed to 2, and let's change the color to say B. Let's show the marker as star. This will be the seventh graph that will be showing out here. This will be the eighth. This will be the ninth. So, okay. So now you can see the subplots. Somehow I've missed out on the fifth plot. Now let's rerun. So now let's take this example and try to understand this. So this is a single plot that we are building in this multiple subplots that we are shown. So we are referring to the ninth plot. So the ninth plot is the this one. So 3 represents the number of rows. The other attribute is for the number of columns, which is 3 in our case. And the last parameter is of the index. So in that, we are passing out the color blue, the shorthand for the marker style, and the line style. So this is how you can build a subplot. For example, if you are having a data set and you want to visualize all the attributes, like all the columns at one place, so you can use the subplot for that. So also there is another functionality for NumPy where we can visualize complex calculations. Like for example, if we are having some kind of formula, for that let me define an array which will take numbers from 1 to 15 at a step point of 5, and the formula is, say for instance, 2 into k plus 3. So this is a mathematical formula, and now you want to plot this. So let's give it a title as complex x label. Let's term it as x axis, and let's plot this using the plot function plt.plot and pass the data points x and y. So now you can see that this complex formula can also be visualized with the help of matplotlib. Now let's move on to a very important plot or chart that is present inside the matplotlib, which is the bar chart. So let's see how we can visualize this. For that, I'll take a variable in the form of a list, and another set of pairs. And let's see which function we can use to build a bar chart. So if we explore the options, we'll find a bar here. If you press Shift and Tab, we can find the various attributes present inside this. So there is an X, there is an height, there is a width, there is a bottom, there is an align, and there is a data. So we'll see what are the necessary attributes out here. Let's pass the variables 1 and 2. Let's use the color as m. Let's do this again for variable 3 and 4. Let's give it a yellow color. I'm passing a title to this plot as bar. Let's run this. So now you can see that we have got our bar chart, and we can easily use this chart for comparisons. So variable 1 and 2, the point 3 and 13 is shown here, like 3 here and 13 here. And similarly, the point 4 and 12. The 4 is out here and the 12 is out here. Like if you want to play with the customization also, so let's change it a bit. Say mgnr. So now what this does is this gives magenta for the first bar, green for the second, and yellow for the third, red for the third. So this is how you can play with it. Let's toll it back to say blue. And yeah, this is how you can compare like two attributes. So a bar chart helps a lot in that. And you can use it for a real-time data set. Let's say if we have hobbies of students in the form of a list, say sports and coding, say cooking, say dance, and one more can be gardening. So there is a group of students out of which 30 wants to go for say sports, 10 like coding, 20 like cooking, and similarly 25 like dance and 10 like gardening. Similarly, we can form a few more groups so that our visualization comes off as very real. Let's change a few numbers. So this is our data, and now let's try to plot it using the bar chart. We pass our data inside. Suppose if we want to pass the group 1. So now you can see, we can visualize the data that 30 students want to do sports as a hobby, 10 want to do coding, 20 want to do cooking, and respectively 25 for dance and 10 for gardening. So now let's see a few more attributes of say this bar plot. Okay, so now if you want this bar plot to be shown as a horizontal bar plot, so you just need to add this H. Let's do this for another group. Give it a different color. Now you can see we have got a horizontal bar plot for us. Similarly, trying out some few attributes. Or say let's group 3. So there is this width which is by default 0.8. Let's try to change this. There was an align as well. Let's give a few more default parameters and line width and line style. Let's say for instance if we give it as double. So these are all the basic parameters that are present inside our bar plot. Okay. It is shown that it's repeated. So see, now you can visualize this better. Like this seems much more interesting than this one. So this was just the understanding of the various arguments that are present inside this. And you can change these values to further explore this option. So now comes another very important plot that is present for matplotlib, that is box plot. So a box plot is a way of representing the distribution of the data based on 5-point summary. So like to better understand the 5-point summary, let's get to this diagram first. So this is basically a diagram of a box plot wherein this tilted line is the minimum, this is the maximum. The Q1 lower quartile is the beginning of this box. The upper quartile Q3 is the ending of this box. And this middle line shows the median. So now let's first understand what are these 3 points. So the 5 points are, the first point of them is the minimum. So inside a data set, the minimum or the least value can be represented as the first quartile, the first value of the 5-point summary. The first quartile is the 25th percent mark. The third point is the median. The fourth point is the third quartile or the 75% mark, and the fifth point is the maximum. So let's take an example and try to use it. Try to understand this 5-point summary using Python. So let's say if we have data, we are giving it an array. Starting it says 0. Suppose this is our array. Or let's try to find out the first most common point, which is the median. So if we use the numpy and the median function inside it, we'll be able to get the median of the data, which comes out to be 71. So among the 5 points, now we can see that the minimum is the 0, the maximum is 213, the median is 71. Let's try to plot this box plot and see for the first quartile and third quartile as well. So say we are mentioning quartile and using percentile from the numpy. and we want our data to be passed on to this and divided in the percentage of 25, 50, and 75. So this quartile is basically defining this box of the box plot, the minimum and maximum which can be extracted using data.min, and similarly for the max function we can use the dot max. So these are inbuilt Python functions .min and .max that we are using. Now let's try to print the 5-point summary. Let's say Q1. Similarly, we can use this statement for getting the third quartile and the median as well. Now pass on this data. This, let's rewrite this. Okay, I have to mention some format specifiers as well. Now you can see that the minimum was 0, the 25th percent of this data set was 41, the median was 71, and the Q3, the third quartile, which is the 75th percent, is 115, and the maximum is 213. Now, see if we want to plot it, let's use plt dot box, pass on data, and there is a attribute known as word, which I'll just tell you, and pass it as true, match underscore artist as false. So see, now you can visualize this box plot and you can see the 5-point summary out here. The minimum is 0, the maximum is 213. The first quartile is the 41, which is represented here. The third quartile is 115, which is represented here. And the median is 71, which is represented by this blue line. So what are the insights given by a box plot is like visualizing the outliers. So for instance, if we had a very big value, say 1,000 inside this, so that will be represented as an outlier beyond this. So it is very useful in that. It is also useful to understand the curve and skewness and helps us in identifying that if the data is symmetrical or not. So in this box plot, this was the minimum. This is known as a whisker. So a box plot is commonly also called as whisker box plot. This is the box. This is another whisker, and this is the maximum point. So I hope this box plot is clear to you. All right. So now let's move on to the pie chart. So a pie chart basically consists of wedges. So each and every, let's imagine a cake. So for example, each piece that we pick out is a wedge inside a pie chart. So let's see how we can present a pie chart. For that, we'll have to mention some labels. Be passed as a list, say ML, say data structure, say web development. So these are the various disciplines that we study, and say cloud computing. Sizes. These are also passed inside a list. Similarly, there is another parameter, say explode. Now let's understand why we have declared so many variables out of nowhere. So let's see. So inside the pie function, we have x, which is the data set. There is this attribute known as explode. There is another attribute known as labels. Colors we have already known, so I have mentioned this parameter here. And let's pass all these variables inside this and try to visualize a pie chart. Okay, so this was label. Now see, now let's understand each and every attribute out of this. So inside the pie chart, we have to provide the sizes of each of this wedge. So this particular slice is known as a wedge. So I have provided for the label ML a size of 245. So that describes to the data points referring to the machine learning label. And similarly for the data structures, say 130 students are applying for data structures. So that is the size of the DSA and a corresponding color. So all these variables are like required in this plot, except this explode. So what is this explode is, if we can see out here that this particular wedge, say machine learning, which is the highest one, is outside of the block, that it is represented a bit more significantly. So for this, we have given the value of 0. 0.3. So now let's change this to see it becomes much more far. Let's tweak some other values as well. Now you can see this is what this explode does. And there is another thing known as auto PCT. So this particular parameter is used to display this percentage. So this percentage is mentioned in a point 0.2 decimal format, which is the access specifiers. Like if we mention it as 0.1, so only one decimal value will be shown. So for each of the visualization that you can do here, we have to use a parameter. Similarly, if we do shadow is equal to true, so then you will be able to see the shadow of each wedge. So this is just about making it more realistic. And this plt.axis equal. This makes sure that by default, the axis of the pie chart is equal. Like this is a 360-degree pie chart. So each of this label is provided each equal angle, which is 45 degree. So this plt.axis makes sure that each label is given the same angle. So this is how a pie chart is used, and we can visualize a lot of data using the pie chart, and it can be implemented using matplotlib in the Python. Let's go on to histograms, and let's see what are the variables required. So for instance, I'm importing random here, and I mentioned CSC score students. So this random function has a parameter known as randint. So this will give us a random integers from 18 to 45, and we require about 100 data points. Similarly, for say another variable ECE students, so now let's try to plot a histogram. Let's pass CSC underscore students in this. Let's So now you can see a histogram. So these basically show the various ages that we have picked up using this random function. Let's give it a title. CSE students. but somehow this is unclear. Like we can't figure out, like from say 15 to 20, what are the number of students that are present, right? So let's define a parameter which is present inside hist, which is known as bins. So bins is basically the container, like the range of the data points that we want to have among two data points. So let's say as per our data is starting from 15 to 45. So these two data points, the minimum is 15 and the maximum is 45. So we'll try to make our bins of that sort. And let's just rerun this code and see if there is any difference. We'll just mention bins. Now see, you can clearly see that among 15 to 20, there are about seven data points. From 20 to 25, this respective 20. Similarly, for 25 to 30, this respective 20, and so on. So a bins is a very important parameter inside a histogram. So how much range should a single bar cover? This is what a bins basically tells us. And bins define how many buckets, like we have to divide the data up into between internals. So like for 15 and 20, this is what we have defined. By default, the bins value is 10, which is allotted to it. So now let's see about some other parameters, which is R width and orientation. So let's say if we are giving R width and orientation, say horizontal. Let's run this. Now we get a horizontal histogram, and the width of this particular bin is reduced from 100% to 90%. So this R width is the width of this specific bin, which was by default 100%. Similarly, like if we want to plot both the data points that we took and differentiate it with a different color, let's get the labels this time as age, and we want the scale to be printed, so we'll use legend. Now you can see that the histogram is shown here, which is the magenta color is for the CSE students, the green color is for the ECE students. Let's provide a label. So if we'll provide a label out here, we'll get the legend. So you can try it out as say CSC. Now you can see the scale as well. So this is about comparing the two data points on the single histogram, and you can convert it also. The orientation can be converted. So you can see the CSC students on the vertical axis and EC students on the horizontal axis. So let us change it to vertical. Now see that this is very good for comparison, but still there is a bit of unclarity. Like I can't see what are the what is the this particular bar plot for EC students, for CSE students, because it is hidden behind this. So let's try to find a solution for that. So this time we'll pass the data points as a list. Say orientation is, and color also in the form of a list. Similarly for the labels. And let's copy this X label and title. Now you can see the simultaneous distribution for the histogram for CSE students as well as ESE students. We can change this to students. So yeah, this is where histogram comes in very handy for comparing two data points, and it gives a very good visualization. Like if we don't have the knowledge of the data points, then we, by just looking at this visualization, we can draw a lot of insights that there are the age of the uh, EC students is much more than that of CSE students. So similar insights can be made. Now, another significant plot that I want to discuss is the scatter plot. So the scatter function plot takes and plots one dot for each observation. So let's see, say for example, number of, for example, for this scatter plot, we are taking the example of having a highway situation wherein about a few bikes go on it every day, and we are trying to track and plot a graph for the speed versus the age of the bike, like how old is the bike. So then we'll be able to get some kind of insights regarding this. Let's pass an array. So yeah, this is the number of years related to each bike. Similarly, you can go for the speed. Can be like 99. So Now let's try to plot a scatter graph for this data. So now you can see the scatter plot for this data, wherein the each bike, how many years old it is, and its respective speed is plotted here inside. Now, for example, if we have another day, like this data for one, this was for one day, and we are having another day and we are keeping a record of the passing number of bikes. So we just have to change this. Let's change the speeds as well. Let's give it another color. Now this shows an error because x and y must be of the same size. So that is why I was counting the number of data points here, and these need to be the same. So let's reduce it down to say 4 each for our own convenience. Now you can see we have successfully plotted the scatter plot for these two data sets, which is of the bikes passing through a highway, and this the relationship is for the number of years old the bike is versus the speed of 2 days. So that is how a scatter plot is made. So now one insight could be made that by comparing the two plots, it is safe to say that both of them gives us the same conclusion, that the newer car and the newer the car is, the faster it drives. So it basically tends to give the insight based on this visualization. So like if you guys have any doubts, so please let me know regarding this scatter plot and histogram. Okay, FF. So now let's just, if there are no doubts, let's just go through a data set and explore this. So first of all, whatever we have learned out of the 6 and 7 plots, let's try to implement it on a data set. So importing the necessary libraries first, the NumPy, the Pandas, Matplotlib as PLT, which is the alias name, using the inline modulus statement so that our charts can be viewed out here, and importing the warnings. So like in the previous sheet also, we saw that there were quite a few warnings given by the Jupyter environment, so which are not required to us. So to ignore those warnings, we can use the statement. Now, I just wanted you guys to download this data set from Kaggle. So Kaggle is a machine learning competition environment wherein there are a lot of notebooks updated, where there are a lot of data updated, and you can compete for each and every competition. So I've taken one such data, a real time data, for you to explore. So you can download it from here, and you have to keep it in your respective folder where you are coding. So let's move on with the data set. So first of all, we'll load the data set. So we'll use the read CSV command, and we'll mention the name of the file here. And this way our CSV file will be uploaded into this variable. Now let's read a few rows, and the first 10 rows is here. So what we can see is there are quite a number of columns and a lot of data available. So say ID, age, experience, income, zip code, and all of these. So let's try to understand about the data types. So each of these variables have a data type. So except this CC average, rest all of the variables are of integer type. Now let's try to find out about if there are any kind of null values. So for that we use the info function. So each of them are having 5,000 non-null values. So that clearly tells us that there are no missing values. Now from Kaggle itself, I got this data description so that we can understand each and every attribute a bit more. So our first attribute is ID, which is the customer ID. The age is the customer's age in the completed years. Experience is the number of years of professional experience. Income refers to the annual income. Zip code is the home address. And respectively, there is a definition for all of this. So let's try to find out the shape, like what is the size of our data set. So there are 5,000 rows and 14 columns. Now, this is just a very small subset of EDA, which is exploratory data analysis, that we usually do in our data science projects. So this was like getting to know about the data types of the attributes and how many rows and columns are there. So these were a few statements, but the major thing starts now for the EDA is uh, let's study the data distribution in each attribute. So for example, our first attribute was say age, because ID is customer ID, which is of no use as of now. We can't visualize it. We can, but we don't have to. That won't make any sense. So let's go for something prominent, which is the age. So I've taken the age of the data set into a variable, say x, and I've found out the minimum comes out to be 23 and the maximum comes out to be 27. So I plotted this using an histogram, like we learned in the previous file. So I got the same tedious, very messy histogram, and I had to get the bins out of it. So to get the bins and to figure out the value of the bins, we have to find the minimum and the maximum of the column that is in contention. And similarly, we'll get the intervals that our bins will make of. So the R width was changed from 100% to 90%, and the orientation was vertical, and the color was given M. Similarly, I've plotted the box plot for the age. And here you can see the 5 point summary again, that the minimum that is shown here, 23, is represented by this line. The maximum is shown by this line. This is a whisker and this is a whisker again. This is the first quartile, which is the 25th percent, which lies somewhere about 45. There is a median which lies somewhere about 45, and the third quartile is somewhere about 55. Sorry, the first quartile was of 35. So this is what a simple box plot can give you for a specific column. Now I've used the subplot again to visualize the age. So now here you have a simple visualization of a box plot as well as a bar plot for the age attribute. And here you can simply see and get an insight that most of the customers' age lies in the age range of 30 to 60 years. So this is clearly evident from this box plot as well as from the histogram. Coming on to another attribute, say experience of this data set. So again used this simple feature and I've plotted in a subplot. Now again we can get an insight about the experience that most of the customer experience lies in the range of 5 to 35. So here it starts and it ends about here. So the prominent number is 5 and the end point is 35. Similarly for the income, I've drawn the same histogram and box plot, and we can get some kind of visualization from it. Also, there is another way to plot a box which is using pandas. So in that case, we just have to use the dot operator and type hist and give the column name. So whatever we have done is through matplotlib, but pandas also has its way to visualize things, though it is very limited. Like you will get a very simple box plot, a very simple histogram, a very simple scatter plot. You won't be able to change the colors. So that is the advantage of matplotlib over pandas visualization. So coming back to the income attribute, so we can get the insight that most customers have an income between the range 10,000 to 100,000, with some customers earning more than 180K, which is shown as outliers. So this is what I was talking about in the box plot visualization. That if there are some data points that will outlast the maximum and they are very few in number, their frequency is very less, so they will be typecasted as outliers. So this is about the histogram and box plot functionality that we use in a real-time data set. Now let's see about the zip code. So the visualization for zip code was not very good. So what I did was I tried to get the max and min out of it. And then I did something using pandas, which is known as value count. So what I'm trying to do is I'm trying to get the maximum number of zip codes that have been used. So this zip code has the maximum occurrency frequency, say 169. And these are the top 5 zip codes that are used in this data set. So I have specified bins with these 5, and then I have plotted the histogram for zip code. So now you can see a very better visualization. So in the previous notebook, we understood about how to organize our plots and how to organize our bins for histogram. So if we do not organize the bins, so we will get the visualization something like this, which is not meaningful. But if we just do some certain Python inbuilt functions, we use some Python inbuilt functions, we get the min and max, then we will able to get the good formation of bins. And you can see the difference between the previous histogram and this histogram. So now we can get the insight that most customers who are part of this campaign are located in this 5 zip code locations. Similarly, for the other attribute which is present is family. So if we do the value counts and plot the histogram and box plot for it, we can have that a family size having 1 has the highest frequency, while the customers having family size 3 have the least. And similarly, I have done for other attributes as well and counted on visualization. So what you can do is I have told you about downloading this data set from Kaggle, importing this and doing EDA on this. So whatever you have learned in this session, you can apply it on this data set and you can further play with the attributes that we discussed in the first notebook. So there is this target column that I wanted to discuss. Yeah. So this is the target column, personal loan, whether a person takes a personal loan or not. So this can also be represented in a form of a bar plot or a histogram. So that gives us a value count of 4520 and 480. So among these 500 customers, only 480 accepted the personal loan that was offered to them in the campaign. Now, we have talked about the advantages of matplotlib, but there are certain disadvantages as well. For instance, let's go back to the first attribute that we discussed, the age. Now, this visualization is good in terms of getting some kind of insights. But our insight was restricted to the point that we were just able to gather the data that the ages lying between 30 and 60. What if we had a Gaussian line coming over here and giving us a better visualization? So that is something that Matplotlib is unable to provide, and that is where Seaborn comes in. So Seaborn is another visualization library which provides a whole lot of other variety of graphs that we can use for our data science projects, and they will help us further in visualizing the data sets. So that we'll discuss in the next class. So for this session, if you guys have any doubts, please let me know in the chat box. So yeah, for the Kaggle link, yeah, you can type about the TheraBank dataset, and the first link is of that Kaggle, so you can derive the dataset. So the difference between PyPlot and Seaborn again. So uh, the difference is determined about the functionality. Let's talk about. So there is this doubt about Matplotlib versus Seaborn. So Seaborn offers a whole lot of variety as compared to Matplotlib. For instance, like when we will learn Seaborn, then you will be able to know more about it. But for as of now, like I'm just comparing this histogram that we have built for the age parameter, right? So this argument, we are able to get the insight only that the age is lying between 30 to 60, like the prominent age is 30 to 60. But what if we had a Gaussian line, like a curved line over this, where we will get to know that this much probability is of the people that is lying in this respective age. So that will give us more insights about the data. So that is something Cball will provide us, and Matplotlib is clearly not providing us. So Matplotlib is an extension of NumPy and Pandas, but Seaborn fits in really well with the visualization part. Matplotlib also offers plots like violin plot, but I have not discussed violin plot because of the fact that violin plots are better represented in Seaborns, which we will discuss in the next session. So I hope your doubt is clear, Afif. Okay, so bins basically is about the containers. So the containers present is a histogram is divided in the form of bins. Bins are basically the range of numbers that we want to highlight. For example, if we are having data points from say 5 to 100, so there are 95 data points. Now there could be a chance that majority of the data points are in the range say 5 to 50. Then our visualization from 5 to 95 100 won't be looking that good. So in that case we have to uh, tweak our bins, and we will range it from 5 to 50 so that our visualization comes out better. So that is a parameter mentioned inside the histograms, and it is referred to as bins. So assignment will be uploaded like after the session, and after the 3 day session. So what I would want is like you implement all the learnings on a particular data set, the learnings of Seaborn as well as Matplotlib and the Plotly library. So I want you to implement it. So this will be a one-way assignment for the 3 days. So guys, any more doubts if there are? No, no. So there are a lot of IDEs present for Python programming. There is Visual Code Studio. There is Eclipse as well. There are online IDEs also. But Jupyter is like very integrated. Like the functionality that you just saw about Shift and Tab, for each function there is a document present, and you can read it and you can implement it. So that is why Jupyter is so popular, and we use Jupyter for Python programming. So the assignment will be uploaded after the 3 day session, David, on the community website. Yeah. So this is regarding the box plot. So the access specifiers used here, basically, what I'm trying to do is I have taken a data set and I'm trying to use this functionality known as percentile, right? So for percentile, we will have to get the format specifiers used in Python, because the percentile that, like, I was when I was running the code, it was not running due to this point that access specifiers were not declared. So point 3f just tells us that how many decimal points should be visible. So in that case, we have used the access specifiers in boxplot. So it has got nothing to do with boxplot. It was because of the understanding of the 5 point summary. So Pooja, you can collaborate bar chart along with the visualize other visualizations as well. So tomorrow in Simon we will understand a type of graph where you can plot in multiple graphs. So a specific face grid would have multiple bar charts, violin chart, bar plots, histogram. So that is why Python has an edge over Excel. Also, guys, like if you want to learn everything from the scratch, zero level, and like you want to become an expert in the fields of web development, AI, Python, and you aspire to become a data scientist or machine learning practitioner, so you can join a PGP program offered by Let's Upgrade for 6 months. So that will be offering a lot of assignments and 15 plus real time projects. So additionally, you will get a placement training course completely for free, and you will also get placement opportunities. So you can refer the website, and there will be an added discount for that as well. So the link is shared. Please refer to it. And if you want to go deep dive into these concepts, please enroll for the PGP program. Rest, if there are no further doubts, we'll catch up tomorrow for the Seaborn session. Sure.
Thank you so much, sir, for the amazing session. But before ending the session, I found some of the issues regarding the attendance. So I'll be here sharing my screen and will like show students how to fill up the attendance. I hope then there will be no issues regarding the same. If in case you have issues, just let me know, guys. I hope my screen is visible to you. So once you have enrolled for the course, make sure you have enrolled for the course already. If not, just enroll for the course. And once you are enrolled, this is the page where you will be landed. Just your feedback is very important for us to improve, and we will like you to give the feedback. So just put any feedback whatever you want to. And yes, that's it. We are done. Attendance has been marked. You can see here. This is as simple as that. And if in case you have not enrolled for the course, then you'll be landed to this page. For example, this is the course. Just click on it, register for the course, and then see here, apply now. Fill up all your details here. Click on apply now, and then you will be landed to the same page which I showed, and then you can give the feedback and your attendance will be marked accordingly. I hope there are no more doubts and you have like already marked your attendance. If not, kindly mark it up. And I guess then we can end the session here. Thank you so much, guys, for attending the session. See you all in the next lecture. Bye.